All right, let's go ahead and get started. I'm trying a different setup today. And we'll have to see if this is if this works any better than my previous one. We're gonna do day 10 today. All right, day 10, Hoof It. You all arrive at a lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area. Your input: perhaps you can find or help fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 to 9. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even gradual uphill slope. For all practical purposes, it means that a hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, or right. You look up from the map and notice the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and others. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have a height of 0. Assembling more fragments of the pages, you establish that a trailhead score is a number of 9 height positions reachable from that trailhead via hiking trail. In the above example, a single trailhead in the top left corner has a score of 1 because it can reach a single 9. Okay. Pathfinding. I think last year I was able to get a pathfinding one done. I'm going to look at the... I need to look at the stream and make sure that this font size is big enough. Seems big enough. I'm going to turn down the music a little bit. Okay. Yeah. Another thing that I want to do, just as a way to keep these things a little bit more consistent, I'm gonna do. Actually, no, I'm not going to worry about that right now. I was going to create some more structure around each day, but I feel like I'm just going to get lost in that, and this one is probably going to be pretty hard. So let's jump over into Advent of Code 2024 Swift. Just prepare 10. Okay, now let's jump over to day 10. Part 1, async throws, returns string. And we will fatal error for part 2 because we're not there yet. This one will do that. And then for running it, we're going to do this. This will grab day 10, part 1. And these two things need to take input. Okay, So I've got that, and then let's go over to day 10 tests. Here I'm going to say, we've got a test, what was that? Test func name. This is going to be test part 1 example. Let input is this. Okay, and then we expect the result to equal a score of 1. How's the font size? Is it is it too small? Okay, so if we run this is going to fail. All right, so let's go grab day 10. All right, so we are probably going to end up parsing this into a grid. Yeah, we definitely are. So let's do grid equals grid with data. The data is going to be or let data equals input dot trimming characters in white spaces and new lines. Then we're going to split on the separator new line, and we're going to map that to an array of the characters in that item. And then we're going to compact, let's see, no, each one of these then needs to be compact map int.init. So our data here should be a 2D array of ints. Looks like that's no, that's we're ending up with this map being problematic again, where it's trying to do it from the parsing library. So if I get rid of this, then all of a sudden it's like, oh, okay. Let's give it a hint here so that we can get the correct compiler errors. This one should be a line in, which should be a string or a substring, string.subsequence. Yeah, I think that if I do line, if we do an array of line, what do we get? Substring.element, that's correct. And then we're going to, yeah, I did this last time too. I can't do compact map int.init. I have to do string $0 and int here, because int doesn't have a substring initializer. Okay, so we are going to need some sort of pathfinder that's going to take a grid of ints, and then we're going to say we also perhaps want, like if we do this in a recursive fashion, we could keep a list of the places we visited. Which would be a bunch of points. Then we would say find trails. Let's see, if we say find path starting from point. And that would return a Boolean if it found a path. Let's do find trails. And then that would return an array of, or maybe just the count. So I need to find where zeros are. And we have grid dot rows data is inside. We did an iterator for the sparse grid, and we did not do it for the regular grid. Or am I mistaken? Search all for element on sparse grid. That's essentially going to be the same thing here. I guess we didn't do an iterator. I thought we had. Let's do the same thing here. Ultimately, this grid and the other grid are essentially the same, except one doesn't store empty spots. But since our map is going to contain every element in the map is going to contain a number, let's just verify that. Yeah, we are going to need every single one. All right, search all for point. This is going to be yeah, we're going to loop over all the rows and all the columns. If we find one, we return the results. Yep. All right, so where are all the starting points? This is going to be starting points is grid.searchAll for 0. This is going to change to return. Okay, so for each one, we need to see, is this a, what they call it? Is it a good hiking trail? These are trail heads. Let's call it trail heads. Good hiking trail. Even gradual uphill slope. And then we're going to pass in a trailhead here, which is going to be a point. And then we're going to basically say trailheads dot map to is good trail dot count. This is going to be find good trails. All right, so here we have a, is it a good trail? I need to, I don't know if I really need this to be recursive. So we're going to start at the trailhead. We're going to look at the neighbors of the current one. If we have nowhere to go or if we're at 9. So while current is not equal to 9, Then I need to find where can we move. We're going to look at all the neighbors. So we're going to say grid.neighbors. Sorry, this needs to be grid current. It's 9. Where, let's see, we need, let's implement this function. Func neighbors for point. That's going to give you an array of point. Should be easy enough. We just need to do -1 to 1, -1 to 1. If it's this one, we continue, we get the neighbor, and we only append it if it's inside. Okay. All right, so for neighbor in grid.neighbors, where grid at that neighbor is equal to the value at our current one plus 1. Let's go grab this function and make it public. We also need this to be, and we haven't visited this one yet. All right, so at this point now, oh yeah, this is why I was thinking recursive, because at this point now we have this neighbor and we need to essentially fork this algorithm because we can have more than one. So let's make a private version of this one that starts from a given point and maintains its visited set. I think that this could just be this. That means we need to say is good trail $0. So we're going to start off at the starting position. We're just going to call this start. So we'll start off at the trailheads. We'll see if visited is no longer going to do that. We're going to say visited.insert our starting point. This is going to be in out, which means that I need this to be maintained for all of them so that they don't overlap, I think. I guess maybe it doesn't matter if they overlap because you're always going up. And if two paths fork, let's say you have a 0 with two 1s, let's say, oh, you can't go diagonal either. So let's say you have two ones going. So I start here, and I have a one to above and a one to my right, and then this one is a two. That's two distinct paths, so it's okay for us to overlap, I think. Okay, if it's a good trail, we can return true if the grid at that start point is equal to is equal to 9, then we return true here. We do need current, though, if we're going to be doing a while loop. I feel like I just need to do that and just do while true. But I don't need while true because we're just going to be moving on neighbors. All right, so let's just start with this. For each neighbor, where the neighbor is exactly 1 plus the one we are and we haven't visited yet, I don't care about that at the moment. Then we're going to say the thing is that this needs to return more than 1. Because one trailhead can produce more than one path. So let's return I guess we would return the array of points that the path is. Let's call this good trails. Then I would need to accumulate my path so far. So then we'd say path.append current. So we'll create a copy of it. Then if our current position is a 9, then we're done and we can return this as a path. That actually needs to be an array of arrays. And that means that each one of these is going to have to do return. No, not return. We need to get. Yeah, so this path is where we are. We'll create an array of good paths. Like this, and then return good paths. So this one is going to be good paths plus equals good trails for that neighbor. I think that could work. Okay, so we'll say Find good trails. Pathfinder is Pathfinder. Grid. Find good trails. Okay, so then for our example, we expect there to be one good trail. I think I'm missing a case here. No, I'm not. If we have no good neighbors, or those neighbors don't produce any good trails, then we return empty, so that'd be fine. Okay, that test succeeded. We don't actually need current. Let's just call this start. If you don't have good neighbors, try making good fences. Nice. Good morning / afternoon. Okay, this trailhead has a score of 2. The positions marked dot are impassable tiles. To simplify this example, they do not appear on your actual topographic map. So that's interesting because that means that this will fail my grid parsing. Let's do test part 1, example 2. Is this? I need to replace. Yeah. I don't quite know what I want to do with my grid parsing since they all have to be an int. I suppose I could replacing occurrences of dot with -1. No, I can't do that either because I'm iterating over characters. Oh, that sucks. I have to change my grid to do this. I suppose I can do map this or int.max or something. So if I can't parse it, then it's just not part of it. That's probably okay. All right, so now this one should be 2. And that one gave me 1. All right, so we have something we can step through. Let's go through our Pathfinder. Change that to a let. So we're going to just print out the path so far and then the position that we're on. Let's see what that gives us for our output. So we're at a starting point of 0. How are we at a starting point of 0? That's wrong. Yeah, our grid is wrong. Print grid. Let's go to this part. All right. How did that happen? Yeah, that's... This didn't copy the way I thought it would. Oh my goodness. That's why. All right, so we're starting at we're starting at 3, 0, which is correct. Then we are looking at 3, 1, which is correct. Then 3, 1 to 3, 2. Then 3, 1, 3, 2, 3, 3. So now we're here. Now this one gets 2, 3. That would actually be really nice for me to print out what value is at that. We're going to do path. I'm going to do path.map to grid $0 so we can see the numbers, and then the grid at start. So I think maybe the numbers are easier to see. So nothing to 0, 0 to 1, 0, 1 to 2, 0, 1, 2 to 3. And then this one to 5. But then we also have another one, 0, 1, 2, 3 to 4. We should have 2 of these. But it's only finding 1. Can I call value of non-function type? Oh, because these are, let's call this trails, and then this is good trails. All right. All right, so we found 1. We found 2. Day 1, part 1, input. This one found 2. How was that? Good trails. Oh, it's a... I have one too many array. How is that? All right, let's do that. Path is going to be a path. This is going to be an array of path. If we're on the last one, then we return this path. This needs to be flat map. That's why. All right, our test succeeded. Let's take a look at this trailhead has a score of 4 because every 9 is reachable via hiking trail except the one immediately to left. All right, so we're gonna try this one. This will be a 4. This does bring me to the point where I know Swift testing has the ability to add test input. Enabled tags. Show me the rest of the docs. parameterized test. That's what I'm looking for. Arguments. Okay, we're going to try this. We're going to test func part 1 examples. Part 1 examples is going to take an array of tuples of input, which will be a string, and the expected number of successful values. This may be a little hard to read, but so if I take that one, this one has 4. And then it's the same thing as this. Sorry, that just needs to be tuple. And so this is going to be args is input and expected count. This will be async throws, expected count. Maybe I can't label it like that. Oh, I'm missing closing. Okay, so let's run this example. Test failed. We got 13. Okay, let's make sure that our example input thing works. Another thing I haven't made use of yet. Yeah, me too. Okay, so I think that this is going to be... the syntax is a little weird with this larger input, but that means I don't have to keep repeating the same test over and over again. All right. So this one let me break if the args.expected count is 4 and run this test again. All right, so p input, this should be args.input, I mean. Okay, so we have one starting point. I can go down. Yeah, let's just jump into it. find good trails. We should have one trailhead. We're going to jump into here. How do I already have this output? This is not the output that I'm looking for. Okay, 3, 0, 3, 1. So that gives me 0, 1, and 2. And just looking at the test value, 0, 1, 2, 3. Okay, so we have 0, 1, and 2. Why am I getting a starting point here? Of 3, 0 again. I wonder if it's running these tests concurrently. Well, that would kind of mess up my strategy here. Let's just comment these out. All right, 3, 0. So we're starting. We've added it to the path. Then we're going to find our neighbors. So there's only one valid neighbor. Zero, 1, 2. I kind of want to find out how many of these neighbors there are. But do that with this type of for loop. All right, so at this point, I'm just going to speed through the rest of it so I get the results. I don't know what you're waiting for here. Weird. Okay, good trails, it says. 3, 0 to 3, 1 to 3, 2 to 3, 3 to 2, 3 to 1, 3, 0, 3, 0, 4, 0, 5, 0, 6. So that's a good one. Then 3, 0, 3, 1, 3, 2, 3, 3. It did the same thing again. How is that possible? I think maybe it's this. So when I'm at, say, number 3, I'm going to add the results of all the good trails. Yeah, by the time I get to a 9, I'm going to return that path. So at this point, I should get this breakpoint 4 times. So my path at this point is 1 through 9. So that's number 2, number 3, number 4. Yeah, so we're ending up computing the neighbors over and over and over again. I think the problem must lie with where it forked. So I'm going to run this again, looking for that 3 case. So let's look at the current number, which is going to be grid of start. So our current number is 0. Now our current number is 1. Now our current number is 2 and 3. Okay, so our neighbor is 2, 3. And then this value is going to be 4. So if I go to find the good trails from that point, I got 10. My path already was 303132. So this is saying from here I can go down 1. That's not right. Is it 30313233? Sorry. Then 2, 3 on this one. But this one also does it. That's... Two, 3, 2, 3, 2, 3. They're all the same path. Let me make sure that so that was the neighbor to the left. If I look at let's see. If I look at the next one, the neighbor is 4, 3, and then this should also be a 4. So that part is correct. So this one gives me one path that looks correct so far. So I went down and then to the right. We're adding 4 to the path. We're not done. So let's figure out how many neighbors we have. Let's do neighbors for start dot filter grid for $0 is equal to grid start plus 1. So we only have one neighbor, which is at 5.3, which is this one. And we step in. So our path now is adding 5.3, which adds the 5. Then from this one, we only have one neighbor. So if I look at good trails for neighbor and path, it's giving me 10 values. Oh, so far I'm good. I only have 3 paths. Each one has 10 values. I guess I was misreading that. Okay. Now, what is our start number? We're at 4.3. And I think we just went to the right. So what is the neighbor? 5.3, yeah. And there's no more here, so we still only have 3 paths. Now we're starting at 3.3 again. I don't know how to get this right-hand pane to like not switch to the active file. Like when it hits a breakpoint. It's really annoying. 3. So we're here again. And our neighbor is 4.3, which we already did. So now Good Paths has 13 values. Samuel, do you notice any difference in quality for the screen on this one? Is it better or worse? I've ended buffering since I opened the stream. Okay, that's good. Seems like my bit rate is kind of low, but I'm also staring at a largely static screen. So if I were to switch to a full screen camera, it would probably jump up. Yeah, difference for today is I'm not using the ATEM to stream, I'm using OBS. And I'm sort of tinkering with the idea that one thing that I don't like about the ATEM is that I end up with a 1080p copy of my screen, which means that my screen has to be 1080p. And then you can't like zoom in, you can't crop, you can't really do anything without it looking blurry. And what I'm doing now is this screen is in 5K and OBS is recording it as 1080p. So then you could still zoom into stuff. Well, I can zoom into stuff. I don't know if this is going to show up. Yeah. Okay. Yeah. So I can zoom into stuff and it'll look nice and crisp. Whereas if I did this with, if I did that with the ATEM, I'm pretty sure it would just look blurry. Yeah, I'll have to check the recording after and see to compare the two. In any case, I am getting sidetracked. Good trails from the starting point to the path. I'm just wondering if I'm just like, I don't want to be accumulating paths I already have, but how is that possible if we're starting from a different neighbor? This is one where I feel like I would love to have a visualization that I could just step through each time through the loop. But I do kind of see, it's hard to know where the problem starts because unless I am returning good paths each time through, so we're going to say from this position, there are good paths.count. Yeah, maybe this will help me figure out where the problem lies. It certainly appears that we're just accumulating duplicate results, but I definitely need the good trails method to return an array because one starting node can have two paths or more. Okay, so from 5-4, there's one good path. Let's filter. From 0-5, there's one good path. From 0-4, there's one good path. Well, let's see. I know that if I reach a roundabout way of getting to the same path, and I know how many good paths from that point, and I'm going to need to cache that. I think that may be part of the problem, and will certainly be a problem with the puzzle input. From 0, 5, there's one good path. Where is my... Let's take a look at the test here. Okay, from here, 1, 2, 3, 4, 5. Yeah, so that's true. There's a one good path from 0, 5. So am I going to have to keep track of starting points to paths and just skip it if I end up in that same one? Because if I end up in a loop, like let's say I go, let's say 3, 4, 5 or whatever, and then that ended up with a few paths, and then this one joined up with that fork. I think that would end up doing the same work over and over and over again. So what if I said our path this needs to be, let's do trail is going to be a point to a path, to an array of paths. How do I want to do that? I would need to pass along the trails. Look up so far. And then we could, if we already have one, we can return it right away. Then here we could do trails start equals good paths. That needs to be maybe we have trails. Private var trails is trails. Then this is a mutating func. I don't really need it to be mutating, because if I could save it here, like this, and then pass it in as an in-out parameter. Without a default. Let's call this cache. This will also tell me where I'm iterating or where I'm duplicating. All right. Oh God, what did I just do? Okay, so we started off with our start point being 3, 0. Then we're 3, 1, 3, 2, 3, 3. Then we did 2, 3. So we're going to the left in our input here. We're here. Then 1, 3. Then 1, 4. Then 0, 4. Yeah, I have a lot of these duplicates. The thing that kind of, oh no, it did find it. 6, 0, this one. Okay, so it did find more than one path. It just duplicated it a bunch of times. These are all duplicates, the ones that end in 6. Yeah, I have 9 duplicates, and then the others are fine. Let's call this neighbor. Paths is good paths, good trails for neighbors. I think that what I'm missing here is that these paths are accumulated up until the very end. So say I'm here and my path is 0, 1, 2, 3. Then I find this neighbor. So for each time through, I'm saying, give me all the good trails from that neighbor. And I'm only returning, I'm returning a trail in 2 places. This one. and this one. And if I hit this one, I think I hit this one more than 2, 3, 4, 5. Let me get rid of this other breakpoint. Interesting. I got that 6 times. Okay, so we started off here, we walked down, then over. This one went to the left. 5, 6, 7, 8, 9. Okay, so from 0, 5, there are 1 good path. Okay, this actually makes sense now. I return a path from 8 to 9. So in the one from 8 to 9, which is here, we're like, okay, I'm going to return that path. So now I go back to 8, and I'm going to be returning that path. Here. That gets added. Yeah, that gets added here. I basically don't want to return Yeah, if there was only one neighbor, then I just want to return, does that neighbor have it? And if that neighbor doesn't have any good paths, it would return an empty array. All right, so the start at this point is 1, 4. Yeah, I think I need to get some distance from this problem. So I think I'm going to call it here. I know I'm missing something simple, but being this close to it and staring at it isn't helping. Well, I hate to throw in the towel on part 1 of this puzzle, but yeah, a lot of times with these sorts of things, I will end up finding a solution later in the day, or the next day, or while I'm sleeping, or whatever. And I think that time is really just the hard part here. But anyway, thanks for joining, and we'll see you again tomorrow for some more Advent of Code.